Welcome to qnawire.
So we have these three motion diagrams for an elevator. The question says, what does it say here? Construct two force diagrams for the elevator. For each motion diagram, be sure that the lengths of the force arrows are the appropriate lengths, right? And that there's a consistency between the force diagrams and the motion diagrams. What assumption do we make, right? So let's assume, here's an assumption, right? Let's assume in B that these are all the same length, right? So in B, it's not accelerating. It's not accelerating up. It's not accelerating down. It's just moving at a constant. If it's moving at a constant speed, then our force, the force is acting in this thing, the force the Earth is exerting is exactly equal to the force at the cable, I'll call it the force of the cable, okay? These guys are equal and opposite. That's because it's not going faster and faster. It's not going slower and slower, okay? Now in A, it's actually accelerating downward. So this could probably be, this is like when you press the button and you start to go down in the elevator, right? Okay, so in this case, the force of the Earth is going to be bigger than the force that the cable's exerting. And that's because it's accelerating downward, okay? And then in C, if you look at C, this thing is actually slowing down. So it was moving down pretty fast. It slows down to stop. So this could be, you could do, this could be your, moving to a lower floor, right? You accelerate to some speed, going down, you maintain that speed, and then you slow down to a stop like this, right? So in this case, the force that the Earth is exerting, these guys are congruent, right? Okay, but in this case, the force that the cable's exerting is bigger, okay? So if you look at the tension in the cable, when you start to go down, the tension in the cable is a little bit less than the weight or the force of the Earth, right? And as it's moving at a constant speed, the force in the cable is exactly equal to the force the Earth is exerting. And then as it slows to a stop, that tension gets more. And this is, if you think about, say, a climbing rope or something like that, right? If you fall on a climbing rope, you're going to be moving down and gravity will be still, that's the force of the Earth, right? Okay, gravity's still pulling down on you and you're accelerating upward. Okay, so this is an upward acceleration. And notice that the force that cable has to exert, in this case, the climbing rope, right, has to be much bigger than your weight, right? In the case of a climbing rope, it would be much bigger because you'd have a tremendous upward acceleration.